Unfortunately, last week, the recordings never completed for our first two parts of the lesson. So what happens is WebEx saves the recordings with a temporary extension. It saves them with a .webx extension, and then it takes typically a half an hour to an hour to convert those to MP4s. And for the first 2 hours of class last week, that process never finished. So when I tried to play the videos to check them, the audio was there, but you couldn't, the screen was blank. The screen capture for some reason didn't work. So what I did was the lesson we did last week was quite similar to my Tuesday class from the week before. So we basically went through and doing the same things. So I've added the videos from the Tuesday class from that lesson into our playlist from last week. So even though it wasn't exactly the same, we did pretty much the same things in the Tuesday class. Okay, so you may notice if you watch the video from last week, you may say, wait a minute, this looks a little different. Why is the Visual Studio application a beer store when we're building a clothing store? So those first couple hours of the video is to do with the beer store that I was building on Tuesday, but we're basically doing the same thing in the Wednesday class. So I just wanted to point that out in case you watch those videos from last week, anything from those videos last week. So what are we doing today? So we did kind of jump ahead a little bit. We got this week. I had planned on talking about SQL Server and getting it set up, but we had time last week, so we got through and we sort of talked about SQL Server. And last week in class, we walked through the process of setting up a database, both locally for our clothing store, as well as setting up a database on Azure. Now, you don't need two separate databases on Azure. So for the clothing store, you really don't need Azure at all. You could just do it all on your local machine. If you already created a database in last week's class, we did go through the process. If you want, you can use that same database for both our clothing store and your assignment. You don't have to create separate databases. You can use the same one if you like. So this week, let's have a look at where our focus really is on the models and the database connections, and using the code generation, the scaffolding tools in Visual Studio to build our controllers and our views. Okay. So we kind of started into this lesson. We got a bit of a head start last week. We already kind of talked about SQL Server. And we had a look at this video. We looked at how popular the product was. And then we went through the process. So these slides are on Blackboard for you to reference in the Lesson 4 folder. It's this item here, these week 4 slides. Oops. So here are the instructions for how we would connect locally, and then the instructions for how you would create a database on Azure, and then how we would connect to it through Management Studio. So we walked through this. This is in the video from part 3 of last week. So if there's anything you need in terms of setting up your database, the instructions are on Blackboard, and the video walkthrough is in last week's in the playlist from last week. So now what we want to do, the other thing is we want to start to connect our database that we set up. We want to connect it into our web application. So we can build models, views, and controllers, so our application can start to create, read, update, and delete operations. So most of the work in .NET in doing this is actually really in setting things up and building the models. Once we've built the models, we can use a few tools in Visual Studio that will automatically build our controllers, build our views for us, which saves us lots of time. So we did do this last week, but I'm just going to go over it at the end of class. Once we created our database, we set up in our appsettings.json, we set up a connection string. So I'm going to open up my project. If you want to open up your clothing store app. And once your project is open, we want to look at the appsettings.json file. So this is our kind of our site configuration. So last week, I created a local database called .NET Duds, and I added the connection string in my appsettings.json. So if I go to Management Studio, I can connect to the database here and I can look at it. It is actually possible to see our database in Visual Studio as well, but the interface is very slow and fairly primitive. So I'll just go to my local server. And here is the .NET database I set up last week. When I expand the tables, there's nothing here. So it's just an empty database. So what I think I might actually do, okay, so I've got my connection info. So if you are connected locally, your connection string probably looks like this version that's in the slides. So if you're connecting to your local SQL server with Windows authentication, this is the default. And typically, your connection string will look like this. I'll put it in the chat. So it would actually probably typically be more like this. So if you set up a database locally, then this would be the connection string that I've put in the chat that should go in your appsettings.json. So this value here for default connection. You'll have to change the server to your computer name, and you'll have to change the database to whatever database name you used. And also just to show you again how you would connect to your local server. When we open up Management Studio, the connection box comes up right away and it remembers any connections you made previously. So if you connected last week, then your local server should already show up here. If it doesn't, your screen might look like this. If you haven't connected before, when you first open the program, it may look like this. The server name is blank and the authentication typically defaults to Windows. So to find your server, you just click the server name drop down and there'll be an option at the bottom that says browse for more. So you just click on that, which brings up a little browse for servers window. And here, if we click on the database engine, it should show you your computer or your server name. So you just select it and you click OK. Windows authentication is the default. So in that case, you should just be able to click connect and that will connect you to your server. On my local server, I use SQL Server Authentication instead, so I have to change that option and enter my credentials. And then if you don't have a database, again, I'm just kind of reviewing what we did last week. Once you're connected to your server, you just right-click and choose New Database and give it a name. Make sure there are no spaces in the name. So we'll take a look at how this connection works. We may have looked at it briefly last week. So there are basically 3 files in our project involved in connecting to the database. The first one is appsettings.json because this sets out our database connection string with our credentials. What database are we connecting to, and what credentials are we using? So that's the first file. The second file is right down at the bottom of my project, and that is the startup.cs file. So in this file, there's already code pre-built for us that will connect our project to SQL Server. And that code is here on lines 30 to 32. So this is an auto-generated file. When we set up the project, we haven't written any code here. So what this code says is when our project starts, we want to add a DB context. The DB context is our database connection class in ASP.NET. So I've kind of defined this here. So we have a class called DB context. It's used for connecting to databases. And when we create a new project, Visual Studio automatically gives us an instance of this in a file in the data folder. There's a file called application DB context. So when our application starts in our startup file, there's automatically code here to configure. So we connect to the database, and it supplies a couple of options. The first option is what type of database is it? And if we're on Windows, this will automatically default to SQL Server. We can change it if we like, but this is the standard. And once we're connecting to SQL Server, we have to provide the connection string. So it looks by default for a connection string called default connection, which is this value in our app settings JSON. So all this code is automatically, it's automatically created, Camilo. So again, this is saving us time. So it's creating a new connection object called application DB context, which is a class in the data folder. So if I just right click my application DB context, I can go to the definition. Or in my solution explorer, I could open up in the data folder. We have this file here called application DB context. So this is our database connection class. So this is, I'll put in a comment here, our auto-generated database connection class. So it inherits from identity DB context, meaning it's used for connecting to databases, but it's a special type of database connection. We're also going to use it for managing user identities. So our users are going to be stored in this database as well. And then we've got some options. So sorry, this is our constructor. And the constructor accepts the options, which are specified here, that we're using SQL Server with this connection string. So all this code is already here for us. We don't have to do anything. The only thing we have to do so far is put in the proper database credentials in our app settings.json. So what we want to do now, and one of the things we're going to do in our assignment, we're going to need models in our project, and we're going to need tables in our SQL Server database. Now, we could build the models in Visual Studio, and then we could go to Management Studio, and we could build the tables here if we wanted to. So I could go into my .NET duds and just start making tables in the Visual Designer. But Visual Studio has a tool that if we just build the models we need for the project, it can auto-generate the tables in the database with a couple of commands using Windows PowerShell. So we're going to do that instead because it's more efficient.
Hey, Rich, it's Mike. Can I just ask a quick question?
Absolutely.
What's the easiest way to test the database connection that is properly connecting? I'll just run the project. Now you set the default connection?
We won't know right away, Mike, because we're not using the connection yet. So we can't actually tell. We're going to have to do some of the other work first. So basically the way we can tell if the connection works is we want to design our models, and then we're going to run those commands to try to generate the database tables. That's going to tell us if the connection is right or not.
Okay.
So when we tried it, when we
retrieve it, and there we go.
Yeah, so when we try to generate the tables, if that connection doesn't work, that process will fail.
Okay. All right. Nice.
Jillian, yes, it's actually a space. It is integrated space security. So as I put it in the chat, or you see it on the slide deck, is accurate. It is a bit strange that they have a space in that property. Just like you can see on mine, it's user space ID, which is strange. This is kind of legacy. This is using an old library, an old syntax from a Microsoft Data Access library called ADO that you might see. So we've got one model. Yeah, I think trusted connection is older. It may work, but I would recommend using the integrated security instead. So we've created a category model, but we now want to design the other models that we need for our store. So I would suggest we're going to need probably four other model classes in order for us to build our shopping cart. So what are some of the other models that we're going to need in our store besides just a category model? Yep, absolutely. We're going to need a product, we're going to need cart, we're going to need orders, and we're going to need one more. We will need users, but that one we don't need to build ourselves because we're using the identity framework, it will build a users table we can use. Yeah, it is kind of neat. We can, Jeffrey. I'm probably not going to, but yes, we can add to the users table. Well, inventory, we could, Daniel, but I would suggest that's probably product. Yeah, Lindsay, we want orders and order details, right? So, when someone is shopping, yep, Kevin will definitely need a cart. So we'll start to design these models. Okay, we can kind of do this together. So we've got a category model. It's pretty simple, just an ID and a name. I'm going to go ahead and make a product model. So I'm going to right click on models and let's add a class called product. Excuse me. From my category, I'm going to copy these two properties. We'll copy the integer ID and the string name property. So categories will have an ID and a name. Product will also have an ID and a name. By default, the way Visual Studio works is it will automatically treat any property called ID as a primary key field. So we don't have to specify. If we wanted to use like a field called, SKU as the primary key, we'd have to designate that's the key. But by any field called either ID or product ID in this model would automatically be treated as a primary key. Again, in category, ID or category ID will automatically be treated as primary key. So I've got a little error here. So how do we fix this error? Saying required is underlined in red. So what's the problem? Yeah, we could just hit Alt-Enter or Control+, or I can click. We need to make a reference to the data annotations library. So now required turns blue, our error goes away. So what other properties, what else should be in our product model? We're building a shopping cart. So every product will have an ID. It'll have name, yep. a description. Okay, so we'll maybe use a double for the price. We'll use a string for the description. We could store the image in the database, but I'm just going to store the image name rather than embedding the actual image file directly. Okay. Now, this is part of, now we're going to come to the relationship part. I've had a conversation with a few students about this for your assignment, because in your assignment, you're going to build at least 2 models, and then you need to figure out, well, what's the are these models related? And if so, what's the relationship look like? You guys would have done this in your relational database class. So now we've got 2 models. We've got category and product. So the things I ask myself are one category is related to how many products. One product is related to. So these are the questions we ask ourselves. Once we've got our independent models, we think about how are they related. So I've put the questions in the chat. So what does this relationship look like? Let's first look at from the perspective of a category. One category is related to how many products? One or many? Right, so one category should have many products. And what about from the perspective of a product? One product is in how many categories? Yeah, for simplicity, we'll say 1. So we won't see the same product in different categories. In a more complicated store, yes, the product could appear in different categories. For our purposes, we'll keep it simple that it's 1 to many. So one category has many products. One product is in one and only one category. So the category is the parent and the product is the child. So now what will we add? How do we relate these together? We're going to have to modify these models to include this relationship. Yep, so we've got primary keys already. So the product needs the category ID as a foreign key, as Daniel and Mike and Jeffrey have all said, right? So every time we create a new product, that product has to have a category ID. We don't want orphaned products that aren't in any category. So now we need to do one more thing for the relationship. Not only do we set out the ID, but we are going to explicitly specify that the product is a child of the category object. So add reference to parent object. Right? So every product has a category. So what this allows us to do is it will allow us, when we're displaying or adding products, it will automatically join the category information. So we don't have to do any kind of SQL joining in order to be able to display products and categories together. So we're going to add this reference in the product class. And now we need to add a reference in the category class instead. So here's our complete product model. Here's the whole thing. I'll put it in the chat in case you need it. Okay, Jeffrey, it knows in 2 ways. We've done half of it. This is the first one. Because of the naming convention, and we're saying this object has a parent object of type category, it will match that to the primary key automatically. We now need to add the reference in the category model. In this case, a category doesn't have one product, it has a list of type product called products. So in the parent model, we're referencing a list. In the child model, we're referencing the parent. Correct. If you name this it's not going to work. It's based on the naming convention. It's because we named this property category ID and we're specifying that every product has a parent of type category. Good question, Jeffrey. And then we're also modeling the relationship from the one side. That one category has an ID and a name. It also has a list of products attached. Yes, the naming conventions are really important. So the only two things I could name my primary key field, I could name it ID or I could name it like this. This would work as well. These are the two standards that Visual Studio would expect. The name of the model plus ID or just ID, either one of these. There's no preference between the two, but don't use something else. Okay, so now we've got two models. Here's the completed category model. Yes, Lindsay, great question. We are going to have multiple references to parent objects because let's think about an order detail, right? An order detail is going to have a product as a parent. It's also going to have an order as a parent, right? So if a customer comes to our store and they buy a pair of pants, a sweater, and a jacket on one order, there are 3 order details. They all belong to the same order parent, but each of them belongs to a different product parent. So yes, an object can have multiple parents. Yep. And an object can also be a parent in one relationship and a child in another. So for example, product is the child in the category product relationship, one category, many products. But product will be the parent, the one side between products and order details. So one product has one category, but it will have a list of order details because the same product can be ordered many times. So by adding these references in our models, when we go to generate the tables, Visual Studio uses these references to create the foreign keys and the relationships. Yeah, in effect, I guess, Kevin, technically it would be the grandparent of the order details because the details would be for the particular products. So we'll design maybe the orders and order details and cart tables maybe a little bit later. We don't need those yet for today. For today, we'll just work on not on the shopping cart part, we'll work on the store management, that we can create categories and populate products into our store. Okay, so our models are complete. I've put the code in the chat if you need it. So we need to do one more step before we can use the tools in Visual Studio to auto-generate these two tables in the database. So we're going to open up our application DB context, our database connection object. And we need to add a couple of things here. Inside the class, we need to reference the data model classes. So we're going to use an object called a DB set, which is kind of like a list, but it can also be used for saving to the database, not only for querying, but for saving. So we're going to create a DB set of type category, and I'll call this categories plural. I also need to declare a DB set of type product. And again, we're missing a reference here, so I can do Alt-Enter and accept the missing reference. So this adds a reference to my models. So this is going inside our application DB context, the database connection object that Visual Studio created for us, and this is in the data folder. The last thing we need to do is we need to override the method when the models are created. This basically fixes a bug. In the identity framework. If we don't put this code in, we won't be able to generate we won't be able to generate our tables. We'll get an error. So we're going to override this method. Yep. So we can add that below the constructor. So here's our constructor. We need to override the model creating. So now we've got two models set up. No, they haven't. We've got two models set up with a one-to-many relationship. Our category has a list of products, and our product has a category ID foreign key and a reference to the parent object. We've modified our database connection class to declare instances of our categories and product models as DB sets. And then we've overridden the onModel creating. So we're set up now. Mike, coming back to your question about how can we test the database, we're about to test it. Okay, so we've created our models. We've named we've said any property called ID or the model name ID will automatically be a primary key. We've updated our application DB context. And now we're going to use a tool called, in effect, basically, Jeffrey, DB set is like an in-memory version of the table. Yes, it's like the in-memory representation of the table. And we can query it and we can add, edit, and delete from it.
Okay.
So for example, if we're adding a new category, it gets added first to this DB set. And then we call a method called save changes that actually commits that change to the database. So these DB sets are in-memory versions that support CRUD. So we're going to use this tool called migrations. So you can read more about migrations here. Basically what a migration is, it's allowing us to take a snapshot of the models in our project and then replicate those models in our database. So rather than building all 5 of the models now. We're going to build product and category today, take a snapshot and update or a migration and update the database so that our database mirrors the models in our project today. When we go and add the orders, order details, and cart tables in another lesson, we'll have to make a new migration. We'll have to take a snapshot of the new model structure, and then we'll update the database to include it. So when we try this, so these are the commands we're going to run. There's a PowerShell window built into Visual Studio that we can use. And Mike, this is going to tell us if our database connection works or not. If our connection's wrong, we're going to get an error when we try to update. We can create the snapshot, but it will fail when we call update database if it isn't connecting to an actual database. So in Visual Studio, I'll save my change here. And I need to go to my Tools menu. So under Tools, about halfway down, there's an item called the NuGet Package Manager. And then that pops open a further submenu called the Package Manager Console. Okay, Kevin, if there's a build failed, then there should be an error message you can click on. That will tell you which file. So I'm going to go to Tools, NuGet Package Manager, and Package Manager Console, and it opens a PowerShell window here. So we're going to run 2 commands. We're going to create a new migration, take a snapshot of our current model structure, and then we're going to push that snapshot to the database. So the command I run, and they're not case sensitive, is add migration. And then I just give it a name describing what's in the snapshot, kind of like a git commit. So I'll call it add migration, create category and product. There can't be spaces in the migration names, I don't believe, or at least it's not advisable. So I'm describing what we did with our models in this migration. So I'll hit enter. So this will compile the project. And then it creates a file here in my Solution Explorer under Data and Migrations. It creates a file with the same name, create category and product, and it actually opens the file. It timestamps it with the current date and time as well, so I know when I made this change, and you can see what the migration is going to do. It's creating a categories table with the columns ID and name. ID will be a primary key, and it will set identity on. So this is like the auto increment feature in MySQL. In SQL Server, it's called identity. So the database automatically assigns the ID values. It creates a products table with these columns. It sets out a primary key of ID and also models our relationship. So it uses category ID as a foreign key. So I'm going to go back to my Package Manager console. Yep, it will also set out any rules. So any rules we put in our models, we're going to modify this a bit later. So for example, if we set up data rules that, for example, like maybe we say name is max length 50 characters, or name is required and shouldn't be null. So we'll run the migration this way. We'll add some validation later, and then we'll write a new migration, which will update the table and add those validation rules so that our database and our models are always in sync. So to actually try to execute it and verify if our database is connected, we run the command update-database. I'll put the 2 migration commands here. So if the database connection, it's using the connection in your appsettings.json. So if that connection is wrong, you'll get an error when you try to update the database. Now, to check if it worked, I'll go back to Management Studio, click on my database, and click Refresh in the Object Explorer. And now when I expand my tables, I have a whole bunch of tables here. So we have the categories table, and we've got the product table with our foreign key constraint. So I don't have to use the migrations tool. I could build the models, and then I could just come to the database and manually build my tables, but the migrations is saving us a lot of work in doing that. Now you'll notice we have a bunch of other tables in the database. I'll explain what they are and why. We've got 1, 2, 3, 4, 5, 6, 7 tables that start with the prefix ASP.NET. From looking at the table names, what are these tables for? Get to your question in a minute, Camilo. What do you suppose these ASP.NET tables are? Yeah, basically for authentication. Because we checked authentication, we changed authentication from none to individual user accounts when we set the project up. When we do that, Visual Studio actually creates a migration. Notice there's a migration right here called Create Identity Schema. And this builds tables for storing user roles and the users so that you can get an idea. This is what our users table is going to look like. It's got fields for hashing, for a security stamp, whether two-factor authentication is enabled. So Jeffrey, coming back to your question, yes, you can modify this table, but it does quite a bit already. So this migration was already here. We just never saw it or never knew it existed. So when we ran the update database command, it actually ran both the migration we made today for categories and product, and it created the migration that got created by Visual Studio when we made our project. If we were to make a brand new project with no authentication, this migration isn't here, and these tables don't get added to the database. So this is part of what the identity library does when we pick authentication at the time we set up our project. This is also why it's easier to set up identity at the beginning when we create the project and not try to add it later on. Camilo, so how do we check our connection? Well, the way to check is to add the migration and run the update database command and see whether it succeeds or not. If it doesn't connect to the database, you're going to get an error here when you call update database. If you get no error, you can then check in Management Studio, and if you refresh your list of tables, you should now have tables in the database. If the connection is wrong, this process will fail. Yeah, Jeffrey, you can do that. Okay, good, Kevin. Good for you. Jeffrey, I find it's easier to make an additional table. I prefer to leave this table and work with it as it is. You can modify it, but then you have to modify a whole bunch of the other kind of pre-built code. So typically, I prefer to just build a separate one-to-one table, but up to you. We're going to be able to work with this for our purposes. Okay, so now let's actually go and make a change. Let's see what happens if we change something in the database. So one thing that you'll notice actually, let's go to our product table. We said the name is required, but But we should probably also make our, let's say we want to make our price required as well. Right now, if we look in the database, our product, oh no, price is not null. Okay. Well, let's see. Here's an issue. Our name is max characters. So our product name could hold thousands of characters. Maybe we want to limit this to something more reasonable, like maybe 100 or 255. So in my product model, I want to set out a max length property of 255. So we don't want the product names any longer than this. We didn't think to specify this when we created the model and generated the database, but now that we've changed the model, we can either go to the database and change it manually. I could go into the design view and modify my table here, or I could just run another migration, which is what I'll do. I'll do it through Visual Studio. So I've added my max length in the product model. I'll go back to my package manager console and I'll add a new migration. This will be a really simple migration. Set product name length. Yep. So now I'll hit the up arrow twice. Yep. So I'm going to update the database. And what the migration does is it runs an alter column command and sets my max length on the name column to 255. So again, if I refresh my tables now, we can now see the name is no longer at max length, it's 255. Oh, it was good question, Jillian. It's warning me because the field name was max and I set the length to 255, it's saying I could lose data. So if we had product names that were 300 characters, it would chop off the last 45 characters once I set it to 255. So that's why it gave me the warning. We didn't have any data in there, so I really didn't care. So oftentimes as we're building an application, we have to change our model. Right. That's right. So it was warning me if I had a product in the database and that had a product name field longer than 255, once I ran the migration, it was going to truncate that value to 255 characters. This didn't affect us because our database is empty. And we'd never have a product name that long anyway. So it was really not any cause for concern. Right. So as we go, we'll add new models over the next few weeks. We're going to make some additional changes to the models today. Like we're going to add some more validation rules. And once we add those validation rules, we're going to want to run a new migration to again update the structure of the tables in the database so that the database rules match the model rules. Okay, so believe it or not, what we've done so far today, we've actually done the hardest part of your assignment, is what we've done over the last 50 minutes. Figure out what models do we need, define the properties of each model, figure out the relationship between the models, and add those child-parent relationships, set up the database connection, reference our models in our DB context, and add this line, this override. This line will never change, so you can just copy and paste it. It's not misconduct. Everyone's project needs this method override. It will look identical. You can just straight copy and paste it in your assignment. And then you can create a migration and update the database. So figuring your models and the relationships and building the database, this is actually the hardest part of assignment 1B. So we're going to take a break. When we come back in 10 minutes, we're going to look at, now that we have a database set up, we can use some other code generation tools in Visual Studio to automatically build our controllers and our views for us. And then we'll start to customize them. And that's basically all I'm asking you to do for this part of the assignment. So most of your work is really just around planning your models and doing in your assignment what we've done over the last hour. So we're going to take a break here. I'm going to stop the recording and I will push what I've done so far up to GitHub. You can use the code, but keep in mind, this has got a local database connection for me. So you'll have to replace this with your own connection string in order for this to work. Okay. So we'll take a pause here. We'll scaffold controllers and views, and then I'm going to show you how we would publish and deploy the whole website to Azure before we go. Okay, so we'll come back in 10 minutes.
Hey, Rich, can you just help me out with, and I'm getting an error when I try to go update